Number 197, your class trick for graphing general rational functions. We have g of x is equal to 5x or x squared plus 5x plus 6, which we can factor to x plus 3 times an x plus 2. And in the denominator, we have x squared plus 3x plus 2, which we can factor to x plus 1 times x plus 2. And so now we have a like term in the numerator and denominator that we can cancel. And we have to remember that we have to include this in our whole. So we have to say that x plus 2 in the denominator cannot equal 0. So our x cannot equal negative 2, meaning that in our function of, in our table of values here, our function is a whole at negative 2 comma negative 1. Also we have this x plus 1 that cannot be 0 in the denominator, so x cannot equal negative 1. This is a vertical asymptote, so we can put that in as a vertical asymptote here. And we can put in the whole, negative 2 comma negative 1. So now we can go ahead and graph this. So choosing x values, we'll get at negative 4, we have a value of 1/3. Negative 3 is 0. Negative 2, negative 1, we have a whole there. At negative 1, it is undefined. At 0, we have a value of 3. 1, we have 2. And at 2, we have 5/3, which is 1 2/3, so it sits right there. Now, connecting the dots, we'll get a graph that looks something like this. And coming up from this side, so it'll look like that. And now notice how we also have a horizontal asymptote that we have to find. So the way we find that is that we choose a very large negative values for x. So let's say we plug in negative infinity for x in the numerator and denominator. So in comparison to negative infinity, so 3 and 1 are negligibly small. So then we would basically have negative infinity over negative infinity, which simplifies to 1. And the same thing occurs when we plug in very large values for x. So if we plug in infinity and infinity for x, so we get infinity plus 3 over infinity plus 1. Infinity is very large compared to 3 and 1. So we can essentially say that that's equal to infinity over infinity, which simplifies to 1 as well. So our vertical asymptote occurs at y equals 1. Which is this line here, y equals 1. So we can say that we have two asymptotes, one vertical at x equals negative 1, and that horizontal asymptote at y equals 1. We have a whole at negative 2 comma negative 1, a y-intercept here at 0 comma 3, and an x-intercept here at negative 3 comma 0.